Let's take a look at how we actually do the calculations for our confidence interval for a mean. So we want to estimate, right, the actual mean SAT score for all seniors, given that that we know only a sample of 40 from that group. We know the 40 is 438. Our sample is 40 out of the total. So what is the actual mean for all seniors if we just have this sample of 40? Well, if you had to come with your own estimate, what do you think? Well, we think 40 is a big number, but we're pretty sure that it's not 438. We're probably thinking it's going to be between two values, and that would be the lower bound and upper bound. Now, you could guess that, which is what I'm having you think about now, but what would an actual confidence interval consist of in terms of what are the lower and upper bound values in that situation? So we would use the formula. We have the given information. We're trying to create a 95% confidence interval. Sorry again about that. 95% confidence interval. So our Z critical is 1.96, which we calculated on the previous section. The mean. And for some reason, let's say we actually know this population for the standard deviation of the population is 105. And then we go ahead and plug in, and you can see we'd get the values. Your point estimate is that original X bar. Your margin of error is calculated by multiplying by 1.96 times the standard deviation divided by square root of n, and you get your values. Remember, you get two values. It's the plus and then the minus. You calculate both of those. So with that, you have this these two values, which then give us a confidence interval. We are 95% confident that the mean SAT scores is between the mean SAT scores for all the seniors is between 405 and 470. Again, that's all we can say because we don't actually know what the mean is for the population. We're trying to estimate it given that sample. And so you probably have some questions. It'd be important to document some questions so that when we talk or you're getting some help on this, you can get clarification on where I got these numbers from. Okay. Well, as we do that first problem, we introduce another situation after that first problem. Is that what if we don't know? How do we actually know the population standard deviation but do not know what the mean is? Like, where would that come from? That would happen because we know we have data already on SAT scores or about our variable of interest, and so we already may have that from a previous study or from previous data, but we don't know currently what the population mean is, right? And so that never happens usually. Rarely do we know the population standard deviation ahead of time. So that creates a peculiar situation or problem for us that then we can't use the population standard deviation formula. In this case, how we calculated Z, right? Because that's a part of that calculation. So what happens is we end up coming up with a new type of value, critical value, right? That follows what we call the T distribution, right? And so here's the formula for the T value. It follows this formula here, where we're going to end up using this here instead of the sigma, right? We use the S, or the sample standard deviation, to do our calculation here. So we're going to end up what ends up resulting is that we end up calculating a confidence interval using a critical t-score and the sample standard deviation. So if you look, this looks very similar to what we had previously for confidence intervals. Where was our formula here? The one that we used to create a confidence interval, Z and sigma. Now we're going to use T, critical T. And again, this is the case when we do not know the population standard deviation. So we can talk more about this. It gets a little bit more technical about what is the T distribution. It has a normal look. It's symmetric, right? Its tails are a little bit wider, so that's why the critical values are a little bit different. And 95% of the values are not within two standard deviations in the sense that what we learned before, but within 2.2, right? 95% of the values on a T distribution. And this is for again, a sample size of 12, which is unique also is that the t-distributions change depending upon your sample size. They grow differently, right? And so that has us introduce a new term called degrees of freedom, because that's what we use to help determine the distribution, the t-distribution or the t-critical values. That's what we end up using to do that. There we go, to do this. And so we'll walk through an example. And so the next piece is going to be finding a critical t value using ArtiStat or StatCrunch, or there's even a t-distribution table to calculate confidence intervals.